Okay, so gonna be recording this solution. I just solved it like 1 second ago, like 3 minutes ago. Let me do that again because my recording failed. Um, so we have here Leetcode daily problem 1161 related to binary tree maximum level sum traversal. Or like maximum level sum, and it involves like level traversal as a BFS. And my idea right now, let's say we have this tree, and I'll start traversing this tree. I'll add the first node to the queue, and I'll start processing this queue. And whenever I start processing a queue, I'll record the number of elements. Initially, going to be one element in the queue. So gonna have while queue, and internally I'm gonna record the level current size of the queue equals length queue. And then I'm gonna go for I in range level, and I'll be popping the element from a start. So I'll do that node. So initially I'll add queue dot append, and then I'll append the root element, and then I'll do the for I in range L. I'll do node equals queue dot pop 0, and then I'm gonna check if first of all I'll have this I'll have the sum here. So gonna be sum here. Sum is equal to 0. Oh no, like, yeah, it's here. Sum is 0, and then I'll have this max sum equals just root dot val initially, and then max sum level equals 1. And then I'm gonna pop the element from a queue and check, and first of all I'll add sum plus equal node dot val, and then I'm gonna go if the node left has is not empty, I'm gonna add it to the queue. If node right is not empty, I'm gonna add it also to the queue. Add node left and node right to the queue. And then lower, when I exited the current kind of level, I'll do the comparison if sum greater than max sum. I'll update max sum equals sum, and I'll update the level max sum level. I'm gonna be equals I'm gonna have this current level, C level, initial is gonna be 1, and this one gonna be C level, and then in the end I wanna increment the C level plus equal 1, and they return in the end max sum level. So in this case, initially, let's say we have this this tree. So this tree. So initially, I have one element in the queue, and I record L is equal 1, and then I go while for I in range L. So for I in range 1, so just one element, I'll pop this root element, and my queue becomes like empty. And I'll check the sum if it's greater than current one, max sum. If yes, I'll update the sum level. But initially, it's like 1. It's like explicitly made it equals to root, so I skip this, and then I add the left and right node, like left and right nodes to the queue. So I'm gonna have this 10 10,250 node populated in the queue. And then I basically exited this loop for in range, and then yeah, and updated some, updated sea level becomes 2, and now again like go through this checking what the level, next level size is, and its size is again gonna be 1, and then I'm gonna pop it again, and then I'll update the queue, and I push the left and right from the 10,000 node, and the left gonna be 98k, and the right gonna be minus 89k. And then again I go through the, I gonna exit because it was just one, the level 2 has size 1. I exited, check the current sum is greater, so before current sum was 989, and now current sum is 10,250. So I'm updating max sum, and I'm updating max sum level by executing this branch. And then I basically exhausted the second level, so I go to the third level. Third level has a size, so this third level has a size of 2, so I have like 2 elements there. So level is equal 2, and I'm gonna go through that and like add them up and save it to the sum. The sum gonna be still less than 10,000 because it's 98 minus 89, so it's around 9,500, like 9,300 something. So I will not update the max sum, but I'll still increase the current level. So then next level gonna be 4, and then there's gonna be only 1 element there in a queue. So the level size gonna be 1, and yeah, and the sum gonna be still lower than the currently recorded max sum. So max sum level will be in this case 2, the output, and that's gonna be the solution. So what I'll do now, I'll program this. So initially I'm gonna have if root is non-check, and if so I'm gonna just return -1. They don't see what I they don't say what I should return in this case, but because I explicitly said that it's optional, it means it might not exist there. So I will return just -1, even though like it seems like not a right one, because like values can be negative. I'll just do that as a placeholder, and then I'm gonna have this queue equals, so just a list, and then I'm gonna queue dot append. I'll add the root, and then I'm gonna have max sum equal root dot val, and then max sum level gonna be 1, and then I'm gonna have this current level is equal 1, and I'm gonna go while queue, that's the main loop, and the loop that's gonna traverse through elements. So on the current level gonna be a level size gonna be len q, and then while like for I in range level size, I'm gonna go q.pop node equals, so sum here are gonna be initial 0, and then node is equal q.pop at the index 0, and then sum plus, I'm gonna update the sum, I'm gonna be node.val, and then if node left is not none, I'm gonna add it to the QQ dot append, and then node left, and do the same if node right is not none. I'm gonna append the node right. So append dot right, append node dot right, and then in the end, when I end traversing current level, I'll check if max sum is less than car is sum, they call it current sum. current sum to align with the current level. If max sum is less than current sum, so I'm gonna update max sum gonna be current sum, and max sum level gonna be current level. And then at the end I'm gonna increment the level. And then return max sum level. So this should be the solution. Let me write to check it. Some typos. Okay. Yeah, so this is a solution. Let's run it again and check. Not that good in terms of like memory. It might be because like I'm saving the current level of the elements. So DFS might be better here. Like just going through the going through the, let's do that DFS. I have some time. Do I? Okay, have some time. So if I do the DFS gonna look something like this. I'm gonna have this void like def DFS, and then I'm gonna have node, and then I'm gonna have this map of sums, like level sums, and it's gonna be dictionary, and then it's gonna be integer, and then integer, and then not gonna be just a tree node, and then I'm gonna return the nothing, and then I'm gonna level sum. So it's gonna be also current level. Level. So I'm gonna go level as an integer, and then I'm gonna go if root is none, I'll return -1. Otherwise, I'll create this level equals level sums equals empty, and then I'll do this call DFS for the root level 1 level sums, and then I'm gonna go for, say we have max sum level equals 1, and then max sum equals root with wall, and then I'm gonna go for I in range 2 up to 1 level sum. I'm gonna check if max x, if level sums for the level, let's call it level, for the level is greater than max sum, I'm gonna update max sum, gonna be level, and then here level, some of it make some minor refactoring, level sum, max sum gonna be level sums level, and then max sum level gonna be equal just level, then I'm gonna return max sum level. Okay, and then I need to implement the DFS for this one, so I'm gonna check I can even do this as an integer. So I'm gonna have level sum, so the first one is 0. and then level sums. Yeah, I didn't do this one. Just I need to update level sums and then root.wall. And then here I'm gonna check if level is equal len of level sums. I'm gonna go and append level sums, append, and then node.wall. Otherwise, else I'll do level sums of level plus equal node.wall. And then I'm gonna go if node left is not none. I'm gonna go DFS node.left level plus 1 level sums, and then if node.right is not none, basically do the same but for the node right. This one should work. Okay, here gonna be just a list of integers. Some minor typos here and there. Love sums. Okay. Submit. Yeah, and it's still not that good. I wonder what other people are doing there. Yeah, that's a little bit better. Oh. I guess there is a Python function that will say it will return the maximum index of the Python function that returns the index of max value in list. List index skipping first. My list. Oh, okay, I can always do subarray. So it's gonna be list index list dot index max. Okay, so first of all I need to do the max equals, let's say, max of the left sums, and then I wanna start from the first one, and then I'm gonna return index, and then it should be input list dot index so it's gonna be max sum dot index of the level sums, index of max sum. No, that's interesting. 1 expected 2, and then here 1 expected 2. Okay, plus 1. that's a little bit faster. What if I gonna skip there? This one probably not gonna be correct. In case of all negatives, I'll just return, yeah. Yeah, in case of all negatives, I'm just gonna return 0. So I can do this root val -1. Yeah, but still not that good. Can I optimize it somehow? So I have like level. Okay, duck. Okay, the Asian duck. Top left. Append. Okay, let's check if this solution node. Yeah, duck is much better in terms of like performance. Yeah, it's 55, sometimes 99, 98. Yeah, I'm gonna wrap up. That's gonna be it.